I'm Ryan. I'm a science teacher.
I'm Cheryl, and I slept through science.
Each episode will tackle a science question you may have learned in school, but can't quite remember or fully explain.
And I'll take the risk of asking the dumb questions so that we can all understand the science we slept through.
The bell has rung. Let's get started. Welcome to lesson 26. We are in our color unit. Cheryl, do you have a colorful question for today?
I sure do, Ryan.
Oh, good.
So you and I, before this podcast, we used to have a travel podcast.
We did. Take me with you.
Yes. It was really fun. And I don't think I ever told you this story. We did our travel podcast for 3 years. So
We did.
we told each other a lot of travel stories, but
Yes, we
I'm
did.
pretty sure I never told you this.
Okay.
So you
I'm
do
intrigued.
know that I went to Alaska one time when I was in middle school, and my family went there together, and we did both some stuff on the land, and then we did a cruise as well. It was a really small cruise.
Right.
And on that cruise, we got to see glaciers and all sorts of animals and all sorts of things. And the one thing that our boat got to see and my parents got to see and my sisters and I did not was the Northern Lights.
Wait, were you in bed asleep?
We were asleep, and they do this thing on the boat where you can sign up to receive an announcement if they see something at nighttime.
Yeah.
And I think our room was signed up for that. Also, our parents knocked on our door, but none of us got up. So they thought oh, whatever, we won't bother them.
Oh.
And so then the next morning we found out that they got to see the Northern Lights. And I'm so bummed about that.
Oh.
And I wish, looking back, I should have just been I don't care how long you have to pound on that door. If you hear about anything cool worth seeing, I want to get up. You know what I mean?
Well, and didn't your parents have a key to get into your room?
I guess not. I don't know. I'm not sure
How
if they
old were
did.
you all?
Well, middle school and high school.
Okay.
Yeah, because I'm the youngest and I was in middle school.
Okay.
Anyway, I still want to see the Northern Lights at some point, but it is crazy to me that I had the opportunity and I was right there.
And they happened while you were there and didn't get to
Yes.
see them. Oh, that's so frustrating.
Yes. Yeah. So anyway, that's definitely one of my travel goals still. But why I'm bringing that to our science podcast is as we're talking about color.
Yes.
I think that's a really interesting color-related thing that happens in nature.
Okay.
And to be honest, I have no idea why it happens.
So your question is, why do the Northern Lights happen?
Yeah.
Okay. Well, let's start with what do you know about the Northern Lights? How about where do they happen?
In the north.
Okay. Everywhere that is north of the equator?
The far north. I don't know.
Okay.
I don't think you have to be in the Arctic Circle. Although on that trip we did go up past the Arctic Circle, and that was cool, but not at that moment. We weren't in the Arctic Circle. But I wonder, do they come from the North Pole? And so if you're far enough north, you can see. Is it at the tippy top of the globe that the lights are coming from, but you can see it if you're far enough north?
Okay.
I don't know. Is there a time of year where they're happening and not, or at least maybe more likely and less likely to happen at different times of year? I know that you see them at nighttime, but is it because they happen at nighttime or because that's when they're visible?
Oh, okay.
Because I'm pretty sure there are stars at daytime, but it's just we have a much brighter star that makes it so we can't see the other stars. But I don't know what they're from. I've heard something about something magnetic, maybe.
Okay.
And I know that there's magnetism in the poles. I don't know why there's magnetism in the poles, but I mean that's the reason your compass works is because of that. But I'd wonder about, if there's a light, there has to be a light source, and our only natural light source is the sun, because like the moon's reflecting the sun.
Mhm.
So is there something reflective happening with the sun that's causing them? Because well, I guess that's not true that our only natural light source is the sun, because there's like glow in the dark weird creatures in the water and stuff like that. So there are other things in nature, I guess, but it's not very common that there's other natural light sources outside
Yeah.
of the sun.
Yeah.
Yeah, those are my thoughts and
Okay.
questions.
Okay. Yeah, let's a few other follow-up questions. Where this is gonna be a really obvious one. Where do you look to see the northern lights?
To the north.
Okay, but let's say you're in the north. Where do you look?
Up?
Okay, do they have to be up, do you think?
Well, they're in the sky.
Okay.
I think they're always, yeah, they're in the sky.
Okay. Okay.
But I think off of the horizon, I don't think they're in the middle of the sky. I think they're like coming
Okay.
off of the earth, maybe.
Well,
It'd be like where you look for a sunset, like along the horizon line.
okay.
Oh, but if you're at the North Pole, I don't know where they would be.
So if you're not at the North Pole, you think you'd look at the horizon, but if you're at the North Pole, maybe you would look somewhere else?
Well, then any horizon you look at is south of you if you're at the North Pole.
Uh-huh.
So I don't know, is it a 360 view or is it
Okay.
directly up in the sky? My guess is it would still be along the horizon line because it's related to the earth somehow.
Okay.
It has something to do with the earth itself.
Yep. And do you think I think I heard you say it's coming from the earth?
I
Do you
think
think it's
so.
coming from the earth's surface and moving up?
Oh, I don't know if it's moving. I think it's some sort of a reflection.
A reflection. Okay.
No, maybe not. Maybe it is something moving that I think there's reflection involved.
Okay.
So even if it's like a substance, I wonder if the sun is reflected. But that would mean only certain times of night you could see it, if that's the case. So I don't know. I guess the other option is it's something that is creating its own light.
What do you mean?
Well, it's either the sun is making a reflection on it, or it's
Mm,
its own light source,
I see.
like glow in the dark bugs in the water.
So you're thinking that like if it's something from the sun, that's where you're getting the idea of the reflection, kind of like the moon's light.
Yes.
Maybe that the sun's light is bouncing off of something on the earth and then reflecting off of the sky.
Yes, or there's something in the sky and the way the sun's reflecting it is like, or maybe the moon is reflecting it and bouncing, like it's the light is coming from the sky and reflecting off of that substance that's in the air.
Okay.
Maybe.
Okay.
Or it's something that causes its own light.
Okay.
But I feel like it's maybe something with the moon or the sun reflecting and
Okay.
like
So there are two
illuminating
options.
it.
Two options are either some sort of reflecting something or something that creates its own light.
Yeah. And I don't know if
Okay.
it's a gas. I would guess it's a gas
Okay.
because my other options are water.
Liquid.
Oh no, liquid. Sorry, not water. Liquid or a solid, but like I don't think it's like, yeah, I think it's some sort of air of some sort that's a gas
Okay.
doing something or other.
Okay. Yeah, you've got a lot of good ideas for me to build on here. With all that information that you shared, Cheryl, there is a lot for me to kind of sift through and try and make sense for you. But you've got pieces that are definitely on track that we can build on.
Cool.
Yeah. Let's start with what really causes the northern lights. You narrowed it down to sort of two sources, either something from the sun that's reflecting in some way, or it's creating its own light, right?
Mhm.
It's actually sort of a combination of the two.
Really?
Sort of. There is no reflection happening,
Okay.
but it is ultimately from the sun,
Okay.
but it's also creating its own light.
All right.
Now you totally get it, right? That cleared it all up.
Yeah, no further questions.
No further questions. The sun is constantly giving off material. Things are streaming away from the sun all the time. Extreme events and examples of that are things like solar flares or coronal mass ejections that you've probably heard of.
Mhm.
But even when that's not happening, there's this material that they call the solar wind. And it's not a wind as in air, obviously, because there's an air in space, but it is blowing or being pushed away from the sun in all directions at all times. And these are particles from the sun that are getting blown off into space. Usually they are little tiny, it's just protons or electrons or a hydrogen atom, things like that. Sometimes they're called cosmic rays, if you've heard that term before.
Mhm.
And they are constantly being blown towards the Earth. One of the other things that you mentioned was that magnetism was somehow involved.
Yeah.
And it is. And this is the Earth's magnetic field, which you may have heard of before.
A little bit.
A little bit. Have you ever seen a diagram with the Earth and then there's these like half circles going from the North Pole to the South Pole, getting bigger and bigger, kind of coming out from the Earth?
Yeah, that sounds kind of familiar.
Yeah. Should I show you a picture? Would that be
Yeah, I would
helpful?
love to see a picture.
I thought that might work better for you.
Mhm.
Hold on a moment.
This is a good reminder for those of you listening to our podcast that we're also on YouTube, and you can just check us out on YouTube to see what kind of ads Ryan gets on the websites he's looking at. And right now we see that shoe ads are happening for
Because
him.
I
So
just bought a pair of waterproof shoes for travel.
it's not
So
funny that after you buy it is
yeah.
sometimes the time where you're like, well, no, now I'm good.
Yeah.
But
Well,
yeah.
there you go. Anyway, here's sort of the diagram. You see the Earth, and then there's these lines that kind of loop from the northern part around to the southern part. And then as you get farther away from the Earth, the loops get bigger and bigger.
Yes.
Okay. That is a representation of the Earth's magnetic field. We can talk about what magnetic fields are and how they work and where the Earths come from and in another lesson if you're interested. But for now, just trust me that the Earth has a magnetic field. And that's why compasses work. And I think you referenced that before, because there is sort of a magnetic pole. That's why we talk about the North Pole and the South Pole. There's a magnetic pole that magnets and electromagnetic things can be oriented around. As these particles, the solar wind comes from the sun, they are charged. They're charged particles, which means they have a positive or a negative charge to them, which means they're affected by an electromagnetic pole or field. So our magnetic field actually deflects and blows away most of those charged particles, which is really good because otherwise those charged particles would slowly remove the Earth's atmosphere.
Oh,
Yes,
interesting.
we're pretty sure that's what happened to Mars's atmosphere because Mars does not have much of a magnetic field at all. And its atmosphere is very, very thin because over time, any atmosphere that it may have had, that solar wind has been able to blow or push out into the rest of the solar system.
Wow.
Yeah, it's a very good thing that we have this magnetic field. However, when we have something like a solar flare or a coronal mass ejection, there's a large amount of these particles that get blown out into space. And if they're pointed directly at the Earth, they can sometimes get through our magnetic field and reach farther down into our atmosphere. But they follow those magnetic field lines. Notice how they're curved towards the poles. And those charged particles get directed towards the North and South Pole along those magnetic field lines. Now pause for a minute and
Oh.
see, is this making any sense?
Yes. Yes, it
Okay.
is.
And that is one of the reasons why you have to be near the poles in order to see the northern or the southern. Did you know there's also southern lights?
I think I had kind of heard of that.
Yeah.
Yeah.
The northern lights are called, do you know what they're officially called?
Oh, it's like Aurora Borealis?
Yeah, Aurora
Okay.
Borealis. And the southern lights are called the Aurora Australis, like
Per
Australia.
Oh, okay.
It's the same phenomenon that just happens on the two ends, because that's where there's those magnetic field lines intersect with the Earth. Is this making sense?
Yeah.
And that's why they end up around the poles, because that's where there's those magnetic field lines kind of run into the Earth. Okay, so that's the first kind of parts.
Yeah.
Now that's where the sun's involved, but that doesn't actually create the light because these particles aren't producing light. However, when they run into atoms that are in our atmosphere, they can what we call excite the electrons that are in those atoms. They can give those extra energy. And when they have that extra energy, those electrons can move around. And in the process of them moving around, they can actually emit light.
Oh, so that's like when we talked about shooting stars, why there's light from that. It's just like it's energy.
It's a different process from shooting stars, but yes,
Okay.
it is because there is energy involved. With shooting stars, it's the compression and the heating that gives
Yeah.
off the light. Here, it's actually on an atomic level. Those electrons get excited and they move up and then they drop back down and release that energy again into photons or light that we can actually see.
Wow.
Yes. And then there's another layer. It also then builds on the lesson we talked about last week with fireworks. The specific colors that we get depend on which atoms in the atmosphere are absorbing and releasing that energy.
Oh,
And
okay.
just like we had different atoms that led to different colors of fireworks, different atoms that are in our atmosphere can release different colors of light for the auroras.
Oh, cool.
The most common one is green, and that comes mostly from oxygen molecules that are relatively high, between 100 and 300 kilometers above the Earth's surface. But you can also have pink and sort of dark red sometimes, which are a little bit lower, and those are only around 100 kilometers, and that's from nitrogen.
Okay.
Then there's sort of a brighter red that can be from oxygen again, but even higher, from 300 to 400 kilometers.
Okay.
And sometimes you can get blues and purples, which are really hard for us to see because they're right on the edge of our visual, the parts that our eyes can actually perceive. And that comes from hydrogen and helium.
Wow.
Yeah.
So that means that they are there during the daytime.
Yes.
Okay.
They are. And in fact, through special satellites, we've actually observed them, not seen them per se, but observed those effects during the daytime when you can have satellites that are looking for those specific wavelengths and can filter out all the daylight.
Wow.
Yeah, it's pretty cool.
And then that also means that if you're on the North Pole, you could just look up and see them.
Sometimes, or sometimes you might have to look south, depending on where it is. Typically,
Yeah.
it creates what they call an aurora oval or halo that's sort of a
Wow.
circle around the North Pole, which means if you're far enough north, they might actually be south of you.
Wow. That'd
Yeah,
be so cool.
yeah, it would be amazing. I agree. Additionally, something else that's pretty cool that I'll show you some pictures here, and I'll put links to all of these in our show notes and descriptions, but so that you can see them right now. Here's some pictures from NASA taken from a bunch of different places, but one of the ones that I think is the most cool is from the International Space Station, where they're actually looking down on the auroras. They occur
Wow.
below the International Space Station. And you can sort of see there that oval shape
Yeah.
around the pole. And you can see that there's actually height to them. They are actually not just flat, they actually have height to them, because as those particles are streaming down, they can hit, different particles can hit different atoms in our atmosphere all the way down,
Wow.
which is pretty cool, I think, anyway.
Yeah.
Here you go. Here you can see it with sort of the parts of the ISS, and you can see kind of them streaming around. You can see them off in the back as well, off on the horizon
Yeah.
there. Isn't that cool?
Yeah.
Yeah, it's just the auroras, they're gorgeous and absolutely beautiful. Here's another one where you can see kind of those ribbons and places where you can actually
Wow.
see it. Now, one of the things to keep in mind about the auroras, most of the time, any picture that you would see is not quite what we would see with our own eyes, unfortunately. Oftentimes, the deep, bright, vibrant colors are not quite what you would see if you were there in person. Sometimes it is, sometimes it
Yeah,
matches, but
that makes
oftentimes
sense.
people who are taking pictures are doing some cool things that cameras can do that our eyes can't, like a long exposure photograph, where they can see things that are a little bit dimmer and they can see them more clearly through the camera, because the camera, you can adjust settings. We can't really adjust the settings of our eyes very well.
Yeah.
Additionally, on top of this, one of the other things that you were talking about, an experience where you were able to not see the Northern Lights. In 2018, I got to go to Iceland. And
Yes.
on the last night of our trip, we got to see the Northern Lights.
Really?
And yeah, and it was sort of what you described on the boat that you were on. We had signed up for, if there's ever Northern Lights, you call into our room and you wake us up. It doesn't matter what time. And we did. What our last night there, we got a call. And here's my poor attempt at some of the pictures. This was the best I could get with my phone camera. And it looked way better than this, but you can see the ribbon of green. And it was this weird ethereal, like it moved, but it didn't, like if you just glanced up on it, you wouldn't know that it moved. It's only if you were to stare at it over time that you would actually notice that it moved.
Wow.
And these are not obviously great pictures, because again, with my phone, and my phone was not the best in the world. That's obviously not a great picture. So it tried to capture it. And let's see, once I get through here, I tried to do some video. Video did not work at all. Like here, you can't really even see it. And I had some stuff there. You can see a little blob, but it looked so much better than that. But I do have a picture. Here we go. Now this is with a camera that someone had that they set up to do some of those fancy things. And this is sort of, it's kind of what we saw was halfway between this and that first picture that I showed you.
Yeah.
But on this one, you can see there's some of those kind of like purple reds at the bottom of the green. We did not see that with our eyes. At least I didn't see it. But we did get to see this beautiful sort of dancing thing. It was so cool. It was very, very cool. And I would highly recommend if you have an opportunity. Of course, the challenge is you never know when it's going to happen.
Yeah.
We do, because it's caused by the sun and it takes time for those particles to leave the sun and reach the earth. You definitely have an idea of when it might happen, usually 48 hours ahead of time ish, but it's never a guarantee. It just depends on how it interacts and what the Earth's magnetic field is doing at the time, and whether there's going to be the weather for it. Because if it's cloudy, you can't see it.
Yeah.
So, but it's definitely a cool experience.
That's so fun.
It is. It is. Oh, one more bonus. Sorry.
Yes.
I'm very excited about this, obviously. Did you know that we are not the only planet that has auroras?
No.
Yes. We are not the only planet that has auroras. We have observed auroras on at least 2 other planets, but they're not in the visible spectrum. They're in the ultraviolet part of the spectrum.
Whoa.
Yeah. Let me show you. Here's the planet Jupiter. And you can see up at its north pole.
Oh my gosh.
Isn't that cool?
That's amazing.
Now, again, ultraviolet, our eyes can't see it. Unless we had a special satellite, we wouldn't be able to see this with our eyes. But there are auroras for the exact same reason that we have auroras. And actually, Jupiter has the strongest magnetic field of any planet in the solar system. So it makes sense that it would also have auroras for the same reason.
Yeah.
And then here is Saturn. You can see along the northern pole, and then also here along its south pole, and again in the ultraviolet. So again, it's false color, not what we would actually see. That's why it's a different color here. This one's kind of an orangish color, whereas it was sort of a brightish blue, almost purple on Jupiter. It's just depending on the instruments you have and the way that you interpret it, because obviously they're all colors that we can't see. But yeah, it's kind of a cool thing that you can see out in space.
That's so cool.
I mean, I think so.
Yeah.
I think that's most of what you talked about. As far as the time of year, yes, it does matter. During the equinoxes, we tend to have a little bit better auroras. So the spring equinox and the autumnal equinox in the fall, but it's not always a guarantee, and it's, not perfect. But also, in order for us to see it, like you said, it's got to be night.
Yeah.
And if you're near the poles, the summer, you've got hours and hours and hours and hours and hours of daylight, and sometimes it never gets fully dark. So
Yeah.
the summertime is not a great time to go see the northern
Mm.
lights or the southern lights. But they do technically still occur. You just can't see them. And now it's time for your quiz, Cheryl.
Fine.
Every time.
I know.
You're
Well,
just like, ugh.
I don't like them. I
But
know
you
they're like
always do
important
fine.
for learning or whatever, but
Or
yeah.
whatever. Okay. Well, you'll love this first question then.
Okay.
Are the northern lights caused by the sun or by something emitting its own light?
Yes. Man, I wish questions in school were like that. That would be great.
What do you mean, yes?
Well, it's little it makes me think of the movie Stardust, so I want to call it Sun Dust. I guess it is Stardust because the sun is a star, right?
Mhm.
It's Stardust. It's like little pieces of the sun that have come to our Earth. So it is from the sun, but it collides in really dramatic ways with other atoms that make light, which I still don't totally understand how that all creates light. So that sounds like a different episode for a different day.
That does sound like a different episode. Where does light come from? That sounds like a great question.
Yeah.
What causes the different colors of the auroras?
It depends on what chemical it is interacting with.
Okay.
Same as fireworks. They always give off the same color, each individual element.
Yeah.
Each individual element always gives off the same color. Yeah.
Awesome. Great. Although technically you can have slightly different colors, like oxygen gives off the green, but it also can give off a red depending on where it is in the atmosphere.
That's so interesting.
Yeah, it has to do with some of the other things for where the light comes from, but yes, but generally they, yes, give off the same colors.
Cool.
Why are the auroras near the poles?
Because of magnets.
Okay.
I also learned today that the North Pole and the South Pole are called that because it's a magnetic pole.
Mhm.
Didn't know that, so that's
Oh,
fun.
okay.
Yeah. And so that's where the magnetism of the Earth is strongest, and so that's where those pieces of stardust are going to come towards when they come towards Earth.
Yeah. Yeah, it kind of directs them towards that because that's where those magnetic field lines kind of intersect with the Earth. Yeah. Where does the light itself come from? You kind of alluded to this already.
Atoms,
Mhm.
excited atoms.
There you go. Yeah, what excites them?
They're colliding, interacting with these pieces, these fragments of the sun.
Yeah. Yeah. For the purposes of this discussion, yes. Okay. And finally, if we were to be able to see the auroras from where we live in Seattle in Washington, where do you think we would need to look in the sky and why?
To the northern horizon because we are in the northern hemisphere,
Mhm.
so we would have to look. We wouldn't be able to see the southern ones because
Right.
of that. It's too far of a curve around the
Mhm.
Earth. I don't know if you know that the Earth is round, but
Oh, I've
um,
heard that. Yeah,
yeah. Um, actually, if the Earth were flat, then we'd be able to see the northern lights, wouldn't we?
probably.
I mean, there also wouldn't be north, so I guess that's a
No.
different thing. But
Yeah.
and then it would be on the horizon because um it's happening north of us, not
Mhm.
above us.
Mhm. Yeah. And bonus, did you know that sometimes you can see the northern lights along the horizon from this part of the Earth?
Really?
Mhm. You can.
Wow.
Yeah. I'm actually part of a Facebook group that's looking for the auroras in Washington, and they keep track of all of the things that happen with the sun and the magnetic fields and all of that to see when it's most likely that we might be able to see them from here.
Wow.
Yeah, and sometimes you actually can. And sometimes if there's a huge coronal mass ejection from the sun and there's a lot of charged particles, a big what they call solar storm, sometimes that can drive the northern lights farther south. And sometimes it can get farther south so that we could see them. Now, it doesn't happen very often, but it does happen from time to time.
That's really cool.
Yeah, so be on the lookout. Someday you might be able to see them from here.
Oh boy.
Oh boy. I think that's all the time that we have for our lesson today. So why don't you get all your stuff packed up and get ready for my closing remarks. You can follow us on Instagram and Facebook at I Slept Through Science, or on Twitter at Slept Science.
If you have dumb science questions like I do, please send them to us. You can email us at isleptthroughscience@gmail.com, or you can even send us a voice memo and we'll play it on the podcast.
Please rate and review our podcast to tell other people what you think about it, subscribe to make sure you don't miss an episode, and share about our podcast on social media.
Thank you to Beth Reed Miller for the artwork. You can check out more of Beth's artwork at Beth Is Something. Okay, great. Thanks. Bye.
The bell doesn't dismiss you. I dismiss you.